Alright, so what we're looking at here in this section is we're going to start looking at graphing linear equations. You know, we're not looking at, you know, qualitative graphs anymore. That was kind of a basic idea, but we're going to start getting into, you know, the algebraic side of things. So what do we mean by a solution and satisfy solution set? What do we mean by these things? Well, you know, they're the basic fundamental terminology or definition sort of thing that allows us to define, you know, the solution or the solution set to a given equation. And, you know, when we solve an equation, what we're saying is we're trying to find its solution set. So, for example, if I have the equation, you know, this is a very basic equation, y equals 3x minus 1, and we're asked to find y when x equals 2. All we're doing is, so when x equals 2, we just plug it in here to find what y is. So if I do that down here, so the equation y equals 3x minus 1, when x is equal to 2, I just take that and plug it in here for x. So that gives me y equals 3 times 2 minus 1, and 3 times 2 is 6 with a minus 1, and 6 minus 1 is 5. So this gives us 5, and that's what I say right here. So y equals 5 when x is 2. And basically what we could do this is we could represent these two values as an ordered pair, 2, 5. And when we represent an ordered pair, it's always represented as x, y, or to be more common, the independent variable, dependent variable. Generally we use x and y, but we can, you know, use other variables as well, just as long as you know which one is independent and which one's dependent. But it's always this. It's always this. Independent, dependent. X, y. So that's what I say here. For an ordered pair x, y, we write the value of the independent variable in the left position and the dependent variable in the right position, which is exactly what I did up here. So if I have an ordered pair x, y, each one of these values are called coordinates. So we have an x coordinate and a y coordinate. That's it. So here, 2 is the x coordinate, 5 is the y coordinate. This is a solution to the equation because it satisfies this equation. When I plug in 2 and I do math, I get 5, which is the y coordinate. And that's what I mean right here, is when an ordered pair is a solution, when you plug in x, you get y as the result. And, you know, if you plug in 2, you get 5 in this equation. The solution set is all of the solutions, an emphasis on all, to the equation. That could be one solution, like in this case, this equation only has one solution. It could have 2 solutions, 3, or it can have infinite solutions. It just depends on the equation that you have. You'll see very soon that this is a linear equation, and linear equations only have one solution. You'll see about that soon. Alright, so if I look here, this example says find 5 solutions to the equation y equals negative 2x plus 1, and plot them on the coordinate system below. Alright, so how do I find 5 solutions to that equation? Well, since x is the independent variable, I can control the value of that coordinate, of that variable. So I could pick x to be whatever I want. I could pick it to be whatever I want. So in order to do this, I'm going to make a table just so we can keep track of all the values for x and then y, the dependent variable. So pick any x values you want. Pick them, any ones you want. It doesn't matter. I'm going to pick some negative values and positive values just to, you know, fill in the gaps. But I'm going to put 0, -1, -2, and 1, 2. I'm going to do that because, and you know, I want to just show you negative and positive values and show you that it works for all kinds of values. I'm trying to find 5 solutions, so I picked any 5 values I wanted for x. Now to find out y, well, just take each one of these values and plug it in here, see what you get for y for each value of x. That's it. You could use your calculator. Here's my TI-84. Let me put it where there's no glare. So, try and get this in here as best as I could. So, here's the equation. -2x plus 1. So -2 times -2 plus 1. Now, in your calculator, I do want to mention this. This right here is the negative symbol. This right here is the subtraction symbol. In the calculator, there's a difference. Like, for example, I'll show you. -2. There it is in the calculator. But if I did that with this symbol instead, I typed in that. If I went -2, it's going to treat that as subtraction. It's not the same thing. Just be aware of that. But when you're actually doing the math, negative and minus are the same thing. So -2 times -2 gives me 4 plus 1. Oops, sorry, I did that one too many times. Let me do it again. -2 times -2 plus 1 is 5. There we go. The lighting's a little better. So now that I have that, I could just write 5 here. Okay. Let's keep going. -2 times -1 plus 1 gives me 3. 0 times -2, you don't need a calculator for that, it's 0. 0 plus 1 is 1. 1 times -2, or -2 times 1, plus 1, -1, and 2 times -2, or -2 times 2, plus 1, -3. Alright, so these are my ordered pairs. This is the ordered pair -2, 5, -1, 3, and so on. 0, 1, 1, -1, 2, -3. So if I want to plot these ordered pairs, I could do that on the coordinate system. So this right here is a Cartesian coordinate system. This is the x-axis. That's the y-axis. So you always start at the origin, and you plot these ordered pairs to make your graph. Now technically you only need 2 ordered pairs, but I'm going to do all 5 just so you can see it. So -2, 5. So how do I plot that ordered pair? Well, you start at the origin for every ordered pair you graph. -2 is the x-coordinate, so I'm going to go to the left 2 because it's negative. So I'm going to go to the left 2, and because the y-coordinate is 5 and it's positive, I'm going to go up 5. So I'm going to go 1, 2, 3, 4, 5. So that right there, that's the coordinate -2, 5. So this one, I'm going to go to the left 1, up 3. So start the origin, left 1, up 3. And that right there is negative 1, 3, 0. So I'm not moving anywhere in the x direction. 1. I'm just going up 1. So I stay here horizontally, I just go up 1. And just keep going. 1, negative 1. Right 1, down 1. 2, negative 3. 1, 2, 1, 2, 3. And those are my ordered pairs. So if I connect those dots, what I end up getting, more or less, is a straight line. Now, you know, it doesn't look exactly perfect, but that's the idea behind graphing linear points. Now, this is a linear equation, and it actually has a specific form, which we're going to talk about very soon, but that's the basic idea. You could graph this in your calculator. If I do that, so if you go to y equals up here, you could actually graph this button right here. And you could graph the equation in the y equals. So if I go negative 2x plus 1, so negative 2, the x variable button, the variable button's right here, x plus 1, I hit enter, and then I go to graph, there it is. Now, I want you to, you know, when it comes to graphing things in your calculator, if you want to keep the dimensions the same, you notice how this goes from negative 10 to 10, from 10 to negative 10. So in the x direction, if you notice, I'm going in increments of 1, right? And it spans from negative 10 to 10. So if I go to the window button here, if you notice, that's what I have in the window button, right? The minimum value for x, that's the x min, is negative 10, right here. The maximum value for x is 10, that's right here. And the scale is by units of 1, which you can see, I go from 0 to 1 to 2, those are increments of 1, and that's the x direction. So the x-axis is set up the way I have it here in my calculator. And if you look at the y direction, everything's the same except for the scale. So the minimum value is negative 10, which is down here, and the maximum value is 10, which is right here. But the scale is in increments of 3, so it's not quite exactly what I have here. If it were, it would be 0, 3, 6, 9, and so on. But to just make it the same as this, just change that to 1, because I go in increments of 1. Hit enter, and now when I graph it, it's going to graph it on the same axes that I have it here. And that's my equation. So, you know, just a little tip for, you know, using your calculator. This window may adjust the view of your graph differently depending on what you have. So, if we go to the next page, so remember how I said this equation has a specific form to it? If you look at it, this is an equation of a line. And you can see that from the plot. And linear equations have a particular form. If an equation could be put into this form, y equals mx plus b, then it's an equation of a line. M and b are constants. This has a particular name, and I'll talk about it later, but if I were to, like, you know, cheat a little bit and look ahead, this is called, and you may know this already, this is called slope-intercept form. And we'll look about that. We'll look at that more detail later. All right. So sketch the graph of 4y minus 8x plus 12 by plotting points. Well, I could plot points right now. Let me label my axes. I could plot points right now, but you know, this equation, I could just make a table and plot in values, but there's something wrong with this right now. This equation, well, it's linear because the exponent is 1 for y and x. So I need to put in slope-intercept form. So how do you do that? Well, you solve for y. So let's take this equation. Let's solve for y. So to solve for y, you're going to isolate the y term. So 4y must be by itself. So to do that, you're going to add 8x to both sides. Oop, and you're going to subtract 12. That's what I meant to say. You're going to subtract 12. From both sides. So the 8x cancels out over here. The 12s cancel there. So on the left side, I'm left with 4y equals 8x minus 12. Now from here, to get y by itself, you just divide by 4. That'll cancel the 4's out. So I'm left with y equals, looks like this now. Now I have 8x minus 12 all over 4. Now I could break this up because there's only one thing down here. So I could break this up. I could write this as 8x over 4 minus 12 over 4. Which reduces to 8 over 4 is 2. So I have 2x minus 12 over 4 is 3. So that looks a lot better. Graphing with that looks a little bit better than graphing with that. So now let's make some values. So again, it says by plotting points. Now technically you only need 2 points. So I'll just say here, bare minimum. Two points or 2 ordered pairs are needed. But you could have as many as you want, as long as it's at least 2. I'll pick 3. -1, 0, and 1. I like to get at least one negative value, that's why I picked those 3. So, alright, whip out your calculator, or just do some mental math. -1 times 2 is -2. -1 times 2 is -2 minus 3, -5. 0 times 2 is 0, minus 3 is -3. 1 times 2 is 2, minus 3, -1. So my ordered pairs are -1, comma, -5, 0, comma, -3, 1, comma, -1. So now just plot those 3 ordered pairs on my coordinates. So -1, start at the origin, left 1, down 5. 1, 2, 3, 4, 5. So right there. That's that one. 0, -3, so I don't move in the x. I can just go down 3 in the y. And 1, -1. To the right 1 and down 1. So if I connect those dots, there's my linear equation. Now, I just want you to know, nothing to it, right? So I just want you to realize here that these are the only three that I picked, right? But if I go up here a little bit, all the solutions of the equation. So this line doesn't just have 3 points on it, just like this line doesn't just have only 5 points on it. There's an infinite number of points on a line. I only found 3. Just like in the previous one, I only found 5. But there's an infinite number of ordered pairs on a line, or any equation for that matter. Let me go back to my calculator. Let's plot this equation again. So let's go back to y equals 2x minus 3. That's my graph. Hey, there's my graph. That's what I got. Cool. Well, if you want to get a table of values, you could do that in your calculator. See this button right? See this value right above graph? It says table. If you hit second graph, it'll take it to the table values. And you know, if I go to the 3 that I picked, which are right here, -1 gives me -5, 0 gave me -3, 1 gave me -1. They're all right. Those 3 are right here. But if I go through the whole table, I could keep my finger on the up button. It's going to go through all the x values forever and ever and ever. You know, that's going to keep going. They're all ordered pairs on that equation, all of them. And if I go to the positive direction, right, it's going to do the same thing. You know, if I kept holding my finger down here, that's going to do that forever and ever. There's an infinite number of ordered pairs on this equation. And these are just whole numbers. If I wanted to go in different increments, I could look at decimal values as well. So, you know, don't just assume that these are the only 3 on there. No. An equation has an infinite number of ordered pairs on it. We only found 3 of them. Okay. Let's go to the next page. Different example here. So, again, this is a linear equation, but it's disguised. How do we put it in slope-intercept form? We solve it for y. So how do I solve this for y? Well, I distribute the 3 here. So if I distribute 3 here, I'm going to get 6y minus 15 equals 2x minus 3 minus 8x. Now, I want to combine the x's together. So 2x minus 8x is minus 6x. And then I have a minus 3. You're combining the coefficients together. I have 2 minus 8, which is negative 6. Alright, so all like terms are combined. Now I just got to get y by itself. How do I do that? Add 15. y equals negative 6x minus 3 plus 15 is plus 12. Divide by 6. The 6's cancel. You have y equals negative 6x plus 12 over 6, and that breaks up again to negative 6x over 6 plus 12 over 6. And that cancels out. Negative 6 over 6, well, the 6's cancel, but I have a negative still there, so that's going to be negative x. 12 over 6 is 2. That's the slope-intercept form. I have a negative 1 out here. You don't see it, but it's there. That's negative 1 times x. We don't write the coefficient 1 there. We just take it for granted. So again, this is much easier to work with than this. It makes the mathematics a lot easier to do. make my table. I only need 2 points, but I'm going to pick 3. I'm going to use the 3 I usually use. And let's use our calculator again. So negative of -1 is going to be +1, and 1 plus 2 is 3. 0, well, negative 0, 0, plus 2 is 2, and 1, well, negative of that is negative 1, plus 2 is +1. So my order pairs are -1, 3, 0, 2, 1, 1. Let's plot them. -1, 3, left 1, up 3. 0, 2, don't move, and I go up 2. And 1, 1, right 1, up 1. So when I connect those dots, here's my linear equation, more or less. You know, that's really the basic idea. By plotting points, that's how you graph a linear equation. It's pretty straightforward. Just get it into slope-intercept form, plot 3 or 2 points, and there you go. And again, you could type this equation in or this equation in your calculator, and it'll still work, but when you use your calculator, it has to be solved for y. So you should use this one. This one's not solved for y, but this one is. So if I go back to y equals, get rid of that, and just press -x. Now remember, when you use negative, you use this number. Negative x plus 2. And then I graph it. And there it is. More or less, it's what I have. The coordinate systems are the same, so, and the window button. So yeah. And again, if you hit second graph, you could go to the table value and you can go through all the values you want. Yep, there's the 3 I used right there. But as you can tell, there are more than just 3 on the line. There's an infinite number of them. Let me show you another little neat trick with your calculator. So you can actually modify this list. Like, let's say you want to go in different increments. If you notice here, this x value goes in increments of 1, right? So if you press second window, it'll take it to the table set function. If I go down, you see this right here? This is delta table. That tells you that's the increments of the values of the x coordinate in the table. So if I go in increments of 1, that's what it's going to be. But what if I want to go in increments of 5? I'll just hit 5 there, hit enter. Now when I go back to my table, if you notice the x coordinate, it's now going in increments of 5. 2 goes to 7, 7 goes to 12, 15, 17, and so on, 22. It goes in increments of 5. Second window, if I go to 10, it'll go in increments of 10. 12, 22, 32, and so on. If I want to get a specific value for x, the independent variable, instead of doing auto, just go over to ask, hit enter. So now when you go back to the table, I want to find the value of y when x is 5,000. Hit enter. Y is negative 4,998. Pretty cool, huh? What's the value of x, or what's the value of y when x was 0? It was 2. Duh. But yeah, to go back to that, just go down to auto, hit enter, and you'll go back to the table. Pretty cool. Alright. So on page 4, what we're going to look at now is intercepts. So knowing what an intercept is pretty important, because among other things it helps us to sketch the graph pretty easily. It's very efficient, you know, with sketches, and as you'll see going forward with a lot of things, it makes it very nice. Okay, so what is an intercept? So an intercept, you know, mathematically, if I want to find the x-intercept, you're going to make y equals 0 and then solve for x. If I want to find the y-intercept, you're going to make x equal to 0 and solve for y. So basically what you're doing is, to find the x-intercept, set y equal to 0 and then solve for x. To find the y-intercept, set x equal to 0 and then solve for y. And you know, the intercept is just the point where the graph crosses the set axis. So this is the x-axis, that's the y-axis. So the x-intercept for this equation is the point where the graph crosses the x-axis. How do I find it? You set y equal to 0 to find the x-intercept. Similarly, to find the y-intercept, you set x equal to 0 to find out where it crosses the y-axis. That's it. So to graph this equation, instead of plotting points like we've been doing, I'm going to find the intercepts. In other words, I'm going to find the x-intercept and the y-intercept. Let's find the x-intercept first. So you're going to set y equal to 0 and solve for x. You know, intercepts are nice because working with 0 is very quick. It makes things go away really nicely. Okay, so when I set y equal to 0 here, well, this becomes 0 equals negative 2x plus 4, right? Now just solve for x. Subtract 4 from both sides. That gets rid of that. So now I'm just going to rewrite this in the opposite order, which is the same thing. I have negative 2x equals negative 4, because these canceled out. So I have negative 2x equals 0 minus 4, which is negative 4. Now to get rid of that, you just divide by negative 2. And what you have is x equals negative 4 over negative 2. That's positive 2. So if I write this as an ordered pair, what is it? When y was 0, x became 2. So x coordinate comma y coordinate, so it's going to be 2 comma 0. That's my x-intercept right there. Plot it. 2, 0. Oop, sorry. I meant to write 2, 0. I almost wrote 0, 2. My bad. Two comma 0. Okay. Now let's find the y-intercept. So in this one, you're going to set x equal to 0. This one's easy. I mean, well, they're both easy, but this one's even easier. Plug this, you're going to plug in 0 for x. So you're going to get y equals negative 2 times 0 plus 4. Y equals negative 2 times 0 is 0. Plus 4, that's just going to be 4. So as an intercept, what does this look like? When x was 0, so 0, comma, y was 4. That's my y-intercept. So 0, comma 4 is right there. So those are my intercepts, and since I only needed 2, really, I can make my equation on the line right here. There it is. These are the points where the graph of my line crosses the x-axis and y-axis respectively. That's it. You can see how, that could be more efficient that way, because working with 0 is really nice. Instead of doing things like, plotting points like we did on the previous problem, there's nothing hard about this, but it takes more steps, because you're not working with nice numbers. When you're finding intercepts, it's more efficient, and you get the same result in a much more efficiently, which is nice. So again, intercepts, they're important going forward. They're important to know about. So just keep that in mind. Okay, on page 5, well, I want to look at 2 particular lines, horizontal and vertical lines, or vertical, horizontal. It doesn't matter what order we look at them. So in this example, I want to sketch the graph of x equals 3 by plotting points. All right. Don't be confused by that. Just because, I'll write it up here for reference. Y equals mx plus b. This is the slope-intercept form for an equation of a line. This doesn't look like that, but this is a line. And you'll see by plotting points. Right? So this is the equation I'm given with. I'm trying to draw that. So what are my x-coordinates here? For all the ordered pairs on this line, my x-coordinates are going to be 3. If I picked 3 points, all 3 points are going to have the x-coordinate 3, because that's what my equation is saying. X is equal to 3. Y could be equal to anything else. This could be equal to, this could be equal to 10 million, for all I know. So my ordered pairs if I plot them, so 3, 0. So I go over 3, and then I don't move in the y direction. So that's 3, 0, 3, 1. And 3, negative 1, so I go to the 3, down 1. So if I plot those points, well, that looks like a vertical line, doesn't it? Because it is. It's a vertical line. Let me go to my calculator. This right here is a vertical line. If I go to y equals, if I'm going to plot the line x equals 3, what do I do? How do I plot this if x is equal to 3? Y equals mx plus b. Well, what does that mean? It means I can't solve for y because I don't have a y. This is a vertical line. So I cannot put this equation into slope-intercept form. But it is still a line. Look at this note here. Any equation, let me fix that. Any equation that could be put into this form, where a is a constant, the graph is a vertical line. And that's what I have here. You know, it's unfortunately I can't draw it in my calculator because I can't get this into y equals mx plus b form because it's a vertical line. You'll see later that vertical lines have an undefined slope. So that's kind of like why we can't draw it or graph it in my calculator. But this is a line. And yeah. So that's what a vertical line looks like. And the last example on this deals with this line. Y equals -5. So if the last example was a vertical line, what do you think this one's going to be? This one's going to be horizontal probably. So -5, -5, -5, because y is always -5. X could be -1, 0, 1. So my ordered pairs and I plot those. 0, -5 is right here. -1, -5 is there, and 1, 5. Oop. I put this, put that in the wrong spot, didn't I? Let me fix that. One -5 is right there. So here's my horizontal line. So this one I could graph because I have y equals a number. So if I go to my calculator, y equals -5, and I graph it, hey, there it is at -5. If I go to my table, as you can see, all the y coordinates are always -5, but the x coordinate could be anything else. You know, if I go to this, what if x was 2? Oh, it's -5. What if x was 10,000? -5. What if x was pi? -5. What if x was 20/3, a fraction? -5. It doesn't matter what this is, it'll always be -5 because that's what y is equal to. So, you know, to summarize, this section, if y equals just a number, then it's a horizontal line. One thing you got to know about me is I don't know how to spell. Well, I do, but I'm very absent-minded when it comes to spelling. This is a horizontal line, but I could also put it in the slope-intercept form, or x equals a number, and I have a linear equation. So, especially, you want to get recognizable. You want to be able to recognize this because we're going to be working with that a lot. When we talk about linear equations, this right here is the bee's knees, man. This is right here is the important thing you got to remember. So, you know, when it comes to, you know, graphing linear equations, plotting points or plotting intercepts are always a good thing to know how to do because it gives you an idea of how to do it. But going on in chapter 1, you know, there are other ways to graph linear equations, and later in chapter 1 we're going to look at a method that you're probably familiar with already. It's called the rise over run method, and we'll do that when we look at the slope of a linear equation. So in section 1.3, which is the next section, we're going to study that little value right there, m. That's the slope of the line, and that's the topic of discussion in section 1.3. So that's the end of 1.2, graphing linear equations.